First of all, I'd like to thank the organizers for the opportunity of taking part in this mini conference, of attending such super talks as we've had this morning and just now by Cara as well. And the chance also to share some views with you about the importance of considering puberty when we look at sleep changes throughout adolescence. So today I'm going to talk to you about two sets of data. First, I'm going to show you some data comparing the effects of pubertal status and age on changes in sleep patterns throughout adolescence. And then I'm going to, at the end, use a couple of minutes to share some ideas of how we can improve measurements of sleep changes in adolescence that I think might be more sensitive to what's really going on at this age. So as we've discussed today, and as you all probably know, as adolescents age, they go to sleep at later times. They rise later if they're allowed to. They have a later dim light melatonin onset, and they also become less sensitive to buildup of sleep pressure as they become older. In my view, the best model that explains these effects is the perfect storm model, and it takes into consideration that there are two main factors that are related to these effects. Some psychosocial factors, which I'm not going to be talking about today, and also some physiological factors. This model also proposes that there is no or little change in dissipation of sleep pressure throughout adolescence. So my question here is, are these physiological changes related to the simple passage of time, or in other words, chronological age, or are they more related to the pubertal status of the adolescents? So although age and pubertal status are positively correlated in that older adolescents tend to be more sexually mature, there are enormous individual differences in terms of pubertal development. For example, it's normal for a girl to begin puberty between the ages of 8 and 13. The same goes for boys between the ages of 9 and 14. So there's 5 years difference there, which is considered just normal. Also, the whole of puberty can occur as fast as, take as little as 1.5 years, and it might take up to 6 years. So when we deal with adolescence, we have a rather awkward situation in that we can have various adolescents who are the same age, but who are in all different stages of puberty. And we also have cases in which we have individuals who are of different ages, but in the same pubertal stage. So determining the role of puberty on sleep changes is quite important, because it allows us to identify both possible mechanisms that are involved in these sleep changes, but also those individuals who are more vulnerable to these effects. In other words, to understand what's really going on in terms of sleep throughout adolescence, we have to try to disentangle the effects of age from those of pubertal status. To do that, we have to measure puberty or pubertal status. And for that, we have to consider that sexual maturity involves two neuroendocrine systems which are independent from each other. One of them is the gonadal system, which ultimately leads to the production of sex hormones by the gonads, such as progesterone and testosterone. And the other system is an adrenal system, which is related to the development of a specific layer in the adrenal cortex called the zona reticularis, which produces a set of different hormones such as DHEA. Now, each one of these groups of hormones will lead to different characteristics, sexual characteristics in the individuals. So we really have to look at all of these to determine at which stage of puberty people are in. This is considered in the gold standard method to measure pubertal status, which is the Tanner method. In this method, we have to have an ND or a nurse practitioner, in other words, a specialist, to assess the development of the children or adolescents, considering whether they are in one of 5 stages of puberty, which are illustrated in a set of images such as these ones here that you see to the right. What the specialist has to do is to compare the development of the child or adolescent to these images in terms of breast growths for girls, genitalia for boys, and the quantity and distribution of pubic hair in the case of both girls and boys. So breast changes and genitalia indicate gonadal changes, and pubic hair indicates adrenal changes. Now, although this is the gold standard method, it's quite expensive, so you do have to have a specialist involved in the research teams, and also a special place in which the children can be seen in private. It also involves getting various children become really embarrassed about this, and there is some resistance sometimes from some families. We must also consider that there's much more going on in terms of puberty, right? Not only changes in genitalia, breasts, and pubic hair. And in the present scenario, I think it's important to point out that puberty is related to the increase in psychiatric symptoms, mainly in girls, right? So there's lots to do with puberty that most studies ignore. There's also another method, which Kara's just mentioned quickly in one of her slides, which can be used to measure pubertal status, which is the Pubertal Development Scale. This is a self-assessment scale with 5 questions, 2 of which are sex-specific. And it's the most common measure used in the literature, except that in sleep changes, for some reason, it doesn't seem to be so. These 5 questions inquire both about gonadal and adrenal changes. So for example, we can have here, have you noticed any skin changes, especially pimples? And the child or adolescent has to determine here if this has not yet started or seems complete, seems to have stopped to have changed. And then we add points here and determine which level of puberty the individual is in. So what does the prior literature really tell us about the difference between the effects of age and pubertal status on sleep changes? Unfortunately, not very much. The effect size is usually really small and don't reflect what we see in clinical practice when we remember when we were struggling with sleep problems in adolescence, and also in our children when we have them. Also, these effects are limited by the fact that they often do not deconfound the effects of age and pubertal status. Many studies use a single marker of puberty, such as menarche or the first menstruation, which is really bad because menarche can happen in all different stages of puberty, in fact. Lots of sleep studies only report gonadal or adrenal changes and not both, or they use a mean score, which is really inadequate. And even longitudinal studies have not managed to disentangle these 2 effects, either because they study children over too short a period or too narrow an age range or pubertal status. So trying to look at this issue in more detail, we conducted a cross-sectional study with a sample of 9 to 17-year-olds, so spanning all of pubertal stages. Our measures of development were age in months, Tanner ratings, and also scores in the PDS. And for sleep, we had scores in the morningness, eveningness scale for children, which is the scale that has mostly been used to assess circadian rhythms in pediatric populations. And we also asked the participants to tell us at what time they went to sleep and woke up on weekends and weekdays, which allowed us to calculate total sleep times, midpoints, and social jet lags. We analyzed this data with general linear models for each one of the sleep measures and looked at how they changed according to each one of the developmental markers in separate models. We controlled in this case for sex and also for social economic status, which is particularly important in places such as Brazil, because we know that more disadvantaged children usually sleep much less. And also because social economic status has an important impact on pubertal development. So what we found, I'm going to show you here the effects only of the models which reach statistical significance with their R-squared effects, which are indications of effect sizes. So we see that for age, for all of our sleep measures, only age was only related to the time that individuals went to sleep on weekdays. Now, if we look at the pubertal measures, we see that the pubertal measures are more sensitive. They pick up more other changes in sleep patterns. The effects related to time of going to sleep on weekdays reached medium effect sizes in most of our measures here, both age and pubertal ones. Adrenal changes managed to pick up various other things, although the effect sizes were small. As I told you, this reflects the general literature. And also in terms of circadian markers, using the morningness, eveningness questionnaire, we had 2 of the pubertal markers which picked that up as well, but also with very small effect sizes. So our results, they confirm the perfect storm model. They seem to show that there is a decrease in sensitivity to sleep pressure following pubertal development and possibly a phase delay also. And there seems to be very little change in dissipation of sleep pressure, because when we inquired about how teenagers felt in the morning, there was very, very little change throughout different stages of puberty or ages. We must remember, however, that teenagers often do not choose when they wake up, right? So, and also that in Brazil, most schools begin at around 7 a.m. So inquiring about how teenagers feel in the morning or what time they wake up in the morning might be confounded by these social issues, which Fernando Lozada is going to talk about later, just after me. So regarding this first set of data, we showed that it's really important to consider pubertal markers in terms of sleep changes throughout adolescence, because they seem to be more sensitive than age to these changes. But it's rather unclear if these effects have to do with gonadal or adrenal changes, and the literature has little to add in this respect as well. Now, I'd like to spend the last couple of minutes trying to discuss how we can improve measurements of sleep changes throughout adolescence. So I think the first point here is that we have to prioritize collecting data on how individuals feel in the evenings, because how they feel in the morning, if the perfect storm model is really correct, wouldn't be very sensitive to changes at different ages or different stages of puberty. It's also important, I think, to look at the morningness, eveningness scale for children or for pediatric populations or better, to see if it's really an adequate measure to reflect what's really changing in adolescence, and whether we can use latent factors of these changes in sleep patterns, because latent factors are considered purer measures of whatever it is that they're trying to measure. So when we look at the MESC, we see that 6 out of 10 questions inquire about how teenagers feel in the morning. So we wouldn't expect this to really change throughout adolescence, and this makes this scale possibly not so sensitive to what's really going on here. Maybe that's why we have such small effect sizes. This questionnaire also has 2 questions which are related to how teenagers feel in the evening. So these are probably really good for us. And there are the remaining 2 questions inquire about time of peak arousal, which have been considered in the sleep literature as indicators of circadian amplitude. So inspired in a recent paper that we published in Chronobiology International, which looked at the factor structure of the morningness, eveningness questionnaire for adults, reran a confirmatory factor analysis to try to see if we could in fact confirm the existence of these 3 different aspects of sleep in teenagers: efficiency of sleep dissipation, sensitivity to sleep pressure or eveningness, and amplitude. And we ran this in a sample of 405 9 to 17-year-olds, and results were really promising. So this is the model that we obtained. It converged, it had adequate to good fit indices, and you can see here that we can obtain latent factors for these different aspects of sleep, which are probably more sensitive. They're purer measures of these aspects of sleep, and they're probably more sensitive to changes throughout adolescence. So in sum, we've showed that sleep pattern changes in adolescence seem to be more related to pubertal trajectory than increases in age. So studies must really try to disentangle the effects of age from the stages of puberty. We also showed that questions that address how teenagers feel in the evening are probably more sensitive to changes throughout adolescence. And the next steps here would be to explore questionnaires such as the MESC to try to obtain latent factors and use these latent factors to see what's going on as adolescents become older or as they become more mature. Probably some latent factors will be more sensitive to change than others, and this will allow us to have a better picture of what is changing in adolescence. So to sum up, or to finish up, I'd like to acknowledge my collaborators and students who worked with me on this project, and also the funding agencies which made it possible. Thanks.